Hey everyone, welcome to the acceleration versus time video of the graphical analysis of the acceleration versus time graph thing. This is the last video in this mini series, right? This is the graph based upon the velocity versus time graph from the previous video. And you will notice that there are two non-zero acceleration sections, specifically between times 1 second and 3 seconds, right? And it has a value of, hey, guess what? Plus 2. That's what I calculated after some math, right? And the other one that's non-zero is -4 between seconds 8 and 9. You will notice that there are no diagonal lines, right? They're all pretty much horizontal, okay? That's because we won't be talking about changing accelerations. Everything you'll see in this course, at least I intend to, will be constant accelerations. Okay? So that means that a constant acceleration has a slope of 0, and that's what we see. Remember, between points B and C, that object was moving at a constant speed. So on that graph, that constant speed was represented by a horizontal line. Well, the same thing here, because a constant speed means that because acceleration is delta v over delta t, if that delta v is 0, acceleration is also 0. And we see that by a horizontal line here. Right? Now, I will grant you that if you're thinking to yourself, but hey, Mr. Trelawney, isn't it impossible that these lines have an exactly corner, right angle? Yes, you're right. If we zoom in, let's get this technology right there. If we zoom in, right, there are whoops, I guess I can't change away. If we zoom in to those corners, so at say 1.01 seconds, just after 1 second, there is a curve. So right there. There's technically a curve. There's a curve downwards there, right? But it's so small, right? The time of that curve is so small compared to the overall time that we can ignore it. The same thing applies for down there, right? So the value of acceleration does not simply go from 0 to boom, 2. Yes, there is a little bit of a curve, but in essence, this happens very quickly, okay? Quickly enough that we can really ignore it, okay? So this is the acceleration versus time graph for this object. Now, let's take a look at all of those graphs together and go back through. So if at the very beginning you pause this video or that video and you tried to predict the motion of this object just based upon the position versus time graph, and you said, well, at point A to B, it speeds up a little bit, right? The position increases, and then it kind of goes for a constant rate, moves at a constant speed because the position changes at a constant rate. And then from C to D, it goes back down to 0, back to a stop. You would be correct. Right? Concave up means that it speeds up. Concave down means that it slows down. The entire time it moves forward because purely looking in the vertical direction from A to D, we're always going up. Always going up over time. The velocity versus time graph shows that from 1 second to 3 seconds, we're speeding up at a constant rate. B to C, moving at a constant speed, right, which corresponds to a straight diagonal line, if you will, and a 0 acceleration, right? And then from C to almost D, from 8 to 9 seconds, concave down, we decelerate, we slow down at a constant rate. So back down, okay? Still moving forward. Still moving forward. And I should emphasize that this graph does not show you the negative velocity half, right? That pink line does never dips into the negative velocities. That should tell you that it's always moving in the plus direction. So plus x, minus x direction. Right? It's simply slowing down, but still going forward. Right? Over here, it's slowing down, but still going forward. And then down on the acceleration graph, that is negative because it's, well, slowing down. So this cannot tell you necessarily the direction of travel. Okay. You could ignore these people that somehow change size. I don't really know what the book was trying to tell you. Yeah, I don't know. I mean, maybe that's what you feel. I don't know. But this value, right, these graphs are from your book in chapter 2. So I would encourage you to go through these, study them, and get familiar with how you can determine the motion of an object based upon a graph. Okay? And that's it. All right. Thanks for watching.